Every year, more than 13 million tons of pineapple leaves are left behind after harvest. For decades, farmers burned them, buried them, or simply left them to rot in the fields. To most people, they are nothing more than agricultural waste, but hidden inside every single leaf is one of the strongest natural fibers on Earth, a fiber so remarkable that luxury brands are beginning to replace animal leather with it. Today, we're going inside the factory that's transforming discarded pineapple leaves into premium leather and ultimately some of the world's most desirable shoes. The journey begins long before the factory, across vast pineapple plantations stretching to the horizon. Harvest season has arrived. Massive tractors and harvesting crews move quickly through the fields. Their goal isn't the fruit. It's what gets left behind. As each pineapple is collected, long, sword-like leaves remain scattered across the ground. For generations, these leaves had almost no commercial value. They were considered a disposal problem. But today, they're worth money, because every leaf contains thousands of microscopic cellulose fibers hidden beneath its tough green surface. Those fibers are incredibly strong, stronger than many tropical plant fibers, exceptionally lightweight, naturally flexible, and completely renewable. The challenge is getting them out before nature destroys them. The countdown starts the moment the leaves are. Fresh fibers contain the highest strength, but as moisture begins escaping, their structure slowly deteriorates. If they're left sitting in the sun for too long, they lose much of the performance that makes them so valuable. That's why speed is everything. Within hours of harvesting, thousands of freshly leaves are loaded onto trucks. Entire mountains of green foliage begin moving toward the processing plant. Watching them arrive is almost surreal. Truck after truck, loaded with what most people would call garbage. Yet inside those trailers is the raw material for luxury fashion. This factory receives nearly 300 tons of pineapple leaves every single day. None of them will ever leave looking the same. Everything changes here. Every minute matters. Every delay reduces quality. Every leaf is another opportunity to recover one of nature's most impressive fibers. Inside the unloading area, conveyor belts immediately carry the freshly harvested leaves toward the first stage of production. From this point forward, the leaves will never see daylight again. Their transformation has officially begun. The first destination is one of the loudest areas in the entire facility, the decortication hall. This is where the factory performs its most violent operation. Because before the fibers can become premium leather, they first have to be completely liberated from the plant. Massive steel rollers grab each leaf with tremendous force. The thick green outer tissue begins tearing apart almost instantly. Juicy plant pulp is ripped away, layer after layer. What remains behind is something surprisingly delicate. Bundles of incredibly fine white fibers. They almost resemble human hair, yet gram for gram, they are stronger than many natural fibers used throughout the textile industry. It is difficult to believe something so fragile-looking could eventually support an expensive luxury shoe. But appearances can be deceiving. The machines never stop. Thousands of leaves pass through every hour. Green pulp pours out one side. Beautiful white fibers emerge from the other. The contrast is extraordinary. The factory is not simply destroying leaves, it is revealing what was hidden inside them all along. And surprisingly, even the waste does not go to waste. The green pulp removed during decortication is not thrown away. Instead, it is collected and reused. Some becomes organic fertilizer returned directly to pineapple farms. Other portions are converted into biogas, generating renewable energy for industrial use. Almost nothing is discarded. Every part of the leaf finds a second purpose. The freshly extracted fibers immediately enter their first washing stage. Crystal clear water flows continuously through enormous tanks. The objective is not simply cleaning, it is preserving quality. Sticky plant sap still coats every strand. If left behind, it would interfere with every manufacturing step that follows. As the fibers tumble through the water, they gently rub against one another. The movement removes residues that the machines could not eliminate. Within moments, the water changes color. Clear becomes green. The remaining sap begins washing away. A second high-pressure rinse follows immediately. Powerful jets strike every bundle from multiple directions. By the time the washing process is complete, the fibers have changed dramatically. Bright, clean, almost silky. For the first time, they begin looking less like agriculture and more like the raw material of a premium textile. But their biggest challenge is still ahead. Right now, these beautiful white fibers are carrying far too much moisture. If they dry too quickly, they become brittle. If they dry unevenly, they lose strength. And if the temperature is even slightly wrong, the entire batch could be ruined. The next stage will determine whether these discarded pineapple leaves become one of the strongest plant-based materials in the world or simply another pile of waste. Only a few minutes ago, these fibers were hidden deep inside tough pineapple leaves. Now they're clean, bright white, and surprisingly soft. But don't let their appearance fool you. Right now, they're also incredibly vulnerable. At this stage, moisture is both their greatest ally and their greatest enemy. Too much, and mold begins to grow. Too little, and the fibers lose the flexibility that makes them so valuable. Finding the perfect balance is critical. The fibers enter one of the most carefully controlled areas of the factory, a drying tunnel stretching nearly 30 meters in length. Unlike drying under the tropical sun, this process leaves nothing to chance. Powerful fans circulate heated air through every bundle, but here's the surprising part. The goal isn't to dry them as quickly as possible. It's to dry them perfectly. Even a small increase in temperature could permanently damage the cellulose structure inside each strand. The fibers would become brittle, weak, and completely unsuitable for premium leather. Instead, every degree is monitored continuously. Humidity, airflow, temperature. Everything is controlled by computer systems working around the clock. The same process that nature would take several days to complete, the factory accomplishes in just a few hours. When the fibers emerge, they've changed once again. Their color from bright white to a soft cream. Their texture becomes lighter, almost cotton-like. And perhaps most impressively, they now weigh only a fraction of what they did when they first entered the factory. Nearly all of the excess water is gone. What remains is almost pure cellulose, light enough to lift with one hand. Strong enough to become the foundation of an entirely new material. Before moving forward, every bundle is inspected. Operators check for discoloration, broken fibers, moisture variations. Anything that does not meet the factory's standards is removed immediately. Unlike ordinary textiles, there are no shortcuts here. One defective batch could affect hundreds of square meters of finished leather. Consistency is everything, but even now, the fibers still are not ready. Although they are incredibly strong, they are also naturally stiff. If woven in this condition, the final material would feel rough and inflexible. Luxury brands demand something completely different: soft, supple, comfortable. To achieve that, the factory relies on biology rather than brute force. Welcome to the biological degumming process. Instead of using aggressive chemicals, specially selected natural enzymes are introduced into large treatment tanks. These microscopic biological catalysts have one specific mission: remove the natural pectin surrounding the fibers without damaging the cellulose itself. It is a remarkably elegant solution. The enzymes do not attack the fiber. They only consume the gummy substances that hold everything together. Hour after hour, the transformation continues. Slowly, the rigid bundles begin relaxing. The fibers separate naturally. They become smoother, more flexible, far easier to process. What would normally take weeks in nature happens here in just 3 carefully controlled hours. This stage requires extraordinary precision. Every tank is constantly monitored. Temperature, pH, enzyme concentration, treatment time. Even the smallest deviation can ruin an entire production batch. If the enzymes remain active for too long, they begin attacking the cellulose itself, instead of creating premium material. The factory would be left with weakened fibers unsuitable for manufacturing. Timing is everything. Once the treatment reaches the exact target, the reaction is stopped immediately. A carefully controlled neutralization process instantly deactivates the enzymes. The fibers are then washed repeatedly. One rinse, then another, then a third, until every trace of the biological treatment has disappeared. Only clean, purified fibers remain. A final, gentle drying stage follows. Notice the difference. This time, the air is not hot, it is only warm. There is a good reason for that. After degumming, the fibers have become much softer, but they are also more delicate. Too much heat now could undo everything the factory has achieved. Instead, a slow, controlled airflow removes the remaining moisture while preserving every strand. The transformation is extraordinary. Just a few hours ago, these fibers were trapped inside rigid pineapple leaves. Now, they almost float in the air. Soft, flexible, silky, yet still incredibly strong. It's difficult to believe they're exactly the same material. Nothing has been added. Nothing artificial has replaced them. The factory has simply revealed the remarkable properties nature had hidden all along. Before the fibers can move to the next stage, scientists inside the laboratory perform one final series of tests. Small samples are carefully examined. Their strength is measured. Their fineness is analyzed. Their moisture content is verified. Every batch must meet strict quality standards before receiving approval. Only then can these once-forgotten pineapple leaves continue their journey, because something surprising is about to happen. Strong fibers alone can't become leather. They first need a partner. A biodegradable material made from corn that will transform millions of loose fibers into a single sheet capable of competing with animal leather itself. The laboratory has confirmed it. The fibers have passed every quality test. They're strong enough, flexible enough, pure enough. But despite their impressive performance, they're still just loose plant fibers. If you tried making a shoe from them now, it would simply fall apart. The factory still has one major challenge to solve. How do you transform millions of individual fibers into a material that behaves like leather? The answer isn't another natural fiber. It's something entirely unexpected. Corn. Inside the next production hall, large containers filled with tiny white pellets wait beside the mixing system. Each pellet is about the size of a grain of rice. They may look like ordinary plastic, but they're anything but ordinary. These pellets are made from PLA, a biodegradable biopolymer derived from corn starch. Unlike conventional petroleum-based plastics, PLA comes from renewable resources and can biodegrade under controlled industrial conditions. It's the perfect companion for pineapple fiber, strong enough to bind the fibers together, yet far more environmentally friendly than traditional synthetic binders. The recipe is surprisingly simple. 80% pineapple fiber, 20% PLA, nothing more, nothing less. That ratio has been refined through years of testing. Too much biopolymer, and the material begins behaving more like plastic than leather. Too little, and the finished sheet won't have enough structural integrity to survive everyday use. Every batch is weighed automatically, every proportion checked twice, because even a tiny variation could change how the material performs months later. The ingredients enter an enormous rotating drum. Slowly, The fibers begin tumbling together with the PLA pellets. The objective isn't simply mixing, it's coating. Every fiber needs to become evenly surrounded by microscopic particles of biopolymer. As the drum rotates, millions of tiny contacts occur every second. Gradually, the entire mixture becomes perfectly uniform. No clumps, no empty areas. Every strand receives exactly what it needs before moving forward. The blended material now travels toward one of the most fascinating machines in the factory, the carding machine. Its purpose sounds simple, but its engineering is extraordinary. Inside, thousands of incredibly fine steel teeth rotate at carefully controlled speeds. As the fiber mixture passes through, those teeth comb every strand individually. Imagine trying to untangle millions of hairs, one by one, without breaking any of them. That's essentially what the machine accomplishes. The once random fibers slowly become organized, parallel, uniform, perfectly aligned. For the first time, they begin behaving like a true textile. Leaving the carding machine, the material barely looks solid at all. It resembles an incredibly thin white sheet, almost weightless, almost transparent. Engineers call this delicate layer a web. Despite its fragile appearance, it already contains the exact composition needed to become premium leather. But right now, even the slightest touch could tear it apart. Its real transformation is still about to begin. Before the web moves forward, sophisticated optical sensors inspect it continuously. Laser scanners measure thickness across the entire width. High-speed cameras search for uneven fiber distribution. Even microscopic variations are detected instantly. Because once the next process begins, there will be no opportunity to correct mistakes. Everything has to be perfect beforehand. Now the web enters what many engineers consider the heart of the entire factory, the needle-punching machine. Unlike woven fabrics, this material isn't stitched with thread, it isn't glued together, and it isn't chemically bonded. Instead, it relies on one of the most elegant mechanical processes in modern textile manufacturing. Thousands of barbed needles begin moving up and down at incredible speed. Each one is finer than a sewing needle. Every time a needle passes through the web, its tiny hooks grab several fibers, pulling them downward, then releasing them inside the layer below. It happens again and again, thousands of times every second, across the full width of the machine. No glue, no toxic adhesives, just pure mechanical entanglement. The loose fibers literally weave themselves together. Watching the transformation is mesmerizing. The fragile web enters one side of the machine. Seconds later, a dense textile emerges from the other. The difference is dramatic. What once floated like smoke now behaves like a solid sheet. 8 successive needle-punching stations reinforce the material even further. Each pass locks more fibers together, increasing strength, improving flexibility, building thickness, layer after layer. The factory carefully controls every specification. A density between 200 and 400 grams per square meter. A thickness of roughly 2.5 to 3 millimeters. Not even a fraction of a millimeter is left to chance. The finished sheet now flows continuously through the production line, more than 2 meters wide, dozens of meters long. For the first time, it no longer resembles pineapple leaves. It no longer resembles loose fibers. It resembles felt, a remarkably strong, flexible, uniform textile. Still cream-colored, still unfinished, but already carrying the strength that will eventually allow it to replace animal leather. Yet one final transformation remains, because right now, it's only a high-performance fabric. In the next department, it will gain color, texture, water resistance, and the unmistakable appearance of premium leather. At this stage, the material is incredibly strong, flexible, lightweight, but if you looked at it, you would never mistake it for leather. It still resembles a thick sheet of cream-colored felt, soft but unfinished. Everything that makes leather look and feel luxurious still has to be engineered. This is where the factory performs its most dramatic transformation. In just a few hours, a plant fiber will become almost impossible to distinguish from premium animal leather. The first stop is the coloring line. Luxury brands do not buy cream-colored material. They want deep blacks, rich browns, elegant tans, or custom shades designed exclusively for a single collection. The entire appearance of the leather begins here. Instead of petroleum-based pigments, the factory uses carefully selected plant-based colorants whenever possible. The pigments are prepared in precise formulations before being applied evenly across the entire surface. Unlike ordinary paint, the goal is not to cover the material, it is to become part of it. As the sheet moves through the coating system, the pigments penetrate deep into the cellulose structure, fiber by fiber, creating a color that remains consistent throughout the material. Once dyed, the leather enters another carefully controlled drying chamber. Temperature is everything. Too much heat, and microscopic cracks begin forming inside the fibers. Too little, and the pigments never fully stabilize. Powerful air circulation removes moisture slowly and evenly. By the time the sheet exits, its color has become permanent, uniform, rich, elegant. It finally begins looking like something you would expect to find in a luxury boutique. But appearance alone is not enough. Real leather survives rain, daily wear, scratches, years of bending and stretching. To compete with that, the pineapple material needs another protective layer. This is where the factory introduces one of its most important ingredients, a water-based polyurethane resin. Unlike traditional solvent-based coatings, this formulation contains no harmful volatile compounds. It is designed to strengthen the material without sacrificing flexibility. As the resin is applied, it flows deep between the interlocked fibers, slowly sealing the entire structure into one continuous surface. Millions of individual fibers begin behaving like a single material. The transformation is remarkable. What was once a textile now feels unmistakably like leather. Every gram matters. The coating thickness is measured continuously. Too little, and the material won't resist water. Too much, and it begins feeling artificial. Computer-controlled systems adjust the application in real time, maintaining perfect consistency from the beginning of the roll to the very end. Now comes one of the most fascinating moments of the entire process: texture. Because leather isn't smooth, its surface contains thousands of tiny natural imperfections. Those microscopic details are what our brains associate with genuine leather. To recreate them, the factory uses enormous heated embossing rollers. As the material passes between them, tons of pressure imprint an incredibly realistic leather grain directly onto the surface. Under your fingertips, it feels almost identical to premium animal hide. Even experienced leather workers often struggle to tell the difference. It's no longer just plant fiber, it's engineered leather for premium collections. One additional finishing step is added. A thin metallic layer is pressed onto the surface under carefully controlled heat and pressure. The result is extraordinary. The leather gains a subtle luxury finish without hiding its natural texture. Soft reflections move across the surface as light changes. Exactly the effect high-end fashion brands look for. This is the version destined for luxury handbags, designer sneakers, and premium footwear collections around the world. But before any customer ever sees it, the material must prove itself. Inside the testing laboratory, samples are subjected to punishing mechanical stress. Abrasion machines rub the surface tens of thousands of times. Flexing equipment bends the material over and over again, simulating years of daily use. Tensile testing machines pull it until failure. Puncture resistance is carefully measured. Every property is compared against international leather standards. The results are impressive. The pineapple leather survives more than 50 abrasion cycles with almost no visible wear. Its flexibility rivals premium animal leather. Its strength exceeds many traditional materials already used throughout the footwear industry, and every square meter produced prevents approximately 12 kilograms of carbon dioxide emissions compared to conventional leather manufacturing. What began as agricultural waste has officially become one of the world's most advanced sustainable materials, but the journey still isn't over, because right now it's only a roll of premium leather. In the next department, computer-guided lasers, robotic systems, and skilled craftsmen will transform it into something every luxury brand understands instantly: a premium shoe. The material has passed every test. It's strong, flexible, water-resistant, and almost indistinguishable from premium animal leather. But at this point, it's still just a giant roll, no different from any other industrial material waiting to be transformed. The final product doesn't exist yet. That happens here, inside the shoe manufacturing department, where precision matters just as much as the material itself. Every luxury shoe begins as a digital design. Before a single shoe is made, engineers use computer software to arrange every component across the leather sheet. The objective is simple: produce as many shoes as possible while wasting as little material as possible. Every square centimeter has value. Every offcut is carefully minimized. Once the layout is complete, the cutting line comes to life. Powerful computer-guided laser cutters move across the leather with astonishing accuracy. Unlike traditional steel dies, lasers never become dull. Every cut is perfectly clean. Every edge is sealed instantly by the heat of the beam. There are no frayed fibers, no rough edges, no additional finishing required. Within minutes, the continuous sheet of pineapple leather is transformed into dozens of precisely shaped components: toe boxes, heel panels, side sections, tongues, every piece needed to build a complete pair of shoes. Robotic arms immediately begin sorting the freshly cut parts. Each component is automatically identified and grouped. Every tray now contains the exact collection of pieces required for one pair of shoes. Nothing is left to chance. Automation ensures every production line receives the correct parts in exactly the right order. From here, the process becomes far more human. Rows of skilled operators sit beside industrial sewing machines. This is where craftsmanship takes over. One by one, the individual leather panels are stitched together. A premium shoe isn't held together by glue alone. Every seam adds strength. Every stitch improves durability. Every detail contributes to the final appearance. High-strength waxed thread is used throughout the process, the same type found in many luxury leather products. Each shoe requires nearly 20 separate stitching operations before the upper is complete. Watching experienced operators work is almost hypnotic. Their hands move with incredible confidence. Years of practice allow them to guide the material through the machines with millimeter precision. Despite being made from pineapple fibers, the material behaves remarkably like premium leather. It bends naturally, accepts every stitch, and resists tearing even under constant needle penetration. That's something very few plant-based materials can achieve. Once the upper has been assembled, metal eyelets are pressed into place. Although small, these components perform an important job. Every time someone ties their shoes, the eyelets absorb tremendous stress. Over months, or even years, they may experience tens of thousands of pulling cycles. Without proper reinforcement, the material could eventually fail. Instead, each eyelet is permanently secured to ensure long-term durability. Now comes one of the most satisfying moments in shoe manufacturing: the lasting process. So far, everything has been flat, but shoes aren't flat. To create their final shape, the stitched upper is stretched over a rigid foot-shaped mold known as a last. Gentle heat softens the pineapple leather just enough for it to adapt naturally. Slowly, the material wraps around every curve, the toe, the arch, the heel. For the first time, it finally looks like a real shoe. The upper now meets its sole, but not just any sole. Many premium models use thermoplastic polyurethane, or TPU, produced with recycled plastics recovered from oceans and coastal environments. It's lightweight, highly durable, and remarkably resistant to wear. Powerful hydraulic presses apply carefully controlled heat and pressure. Within seconds, the sole and upper become permanently bonded, not simply glued together, but fused into a single structure designed to survive years of daily use. At that exact moment, a pineapple leaf officially becomes a shoe. The finishing department adds the final details that separate an ordinary product from a luxury one. Edges are carefully polished. The surface is inspected under bright lighting. Any tiny imperfections are corrected by hand. The insole receives the Ananas Nova logo. Laces are threaded. Every pair is cleaned and carefully prepared. These finishing touches may seem minor, but they're often what customers notice first when opening the box. Luxury isn't only about performance, it's about presentation. Before leaving the factory, every pair undergoes one final series of tests. Mechanical systems repeatedly flex the shoes, simulating more than 100 walking movements. That's roughly equivalent to several years of everyday use. Water resistance tests ensure moisture remains on the surface instead of penetrating the material. Every seam is inspected, every stitch examined, every shoe handled by experienced quality inspectors before receiving approval. Only the best pairs continue, because one final journey still remains. The journey from a factory in the Philippines to some of the most exclusive fashion boutiques in the world. The manufacturing process is complete. What began just 2 days ago as discarded pineapple leaves lying in the tropical fields of the Philippines has become a pair of premium shoes ready to compete with the finest leather products in the world. It's one of the most extraordinary transformations in modern manufacturing. Agricultural waste turned into luxury. Before a single pair leaves the factory, every shoe receives one final inspection, not by machines, by experienced human eyes. Inspectors examine every stitch, every edge, every embossed texture, every lace, every logo. Luxury customers expect perfection. And perfection is exactly what the factory delivers. If even the smallest imperfection is found, the pair never reaches the customer. It returns for repair or is rejected entirely. Quality always comes before quantity. Once approved, each pair receives its own digital identity. A unique QR code is attached inside the packaging. With a simple scan, customers can trace the product back through its manufacturing journey. The factory, the production batch, the materials used, even the pineapple plantations where the fibers originally came from. That level of transparency has become one of the biggest advantages of sustainable manufacturing. People no longer want beautiful products alone. They want to know their story. The finished shoes are wrapped individually in soft tissue paper. Every fold is made by hand. The presentation is just as important as the product itself. After all, the unboxing experience is often the customer's very first impression. The shoes are placed inside elegant matte black boxes. A subtle gold logo is embossed across the lid. Minimalist, premium, exactly what you'd expect from a luxury fashion brand. The box is sealed and prepared for shipment. Hundreds, then thousands, of identical boxes begin filling the warehouse. Each one represents hundreds of pineapple leaves that would otherwise have been burned in the fields. Each one represents thousands of liters of water saved compared to traditional leather production. Each one represents a completely different way of thinking about waste. The factory has not simply created a new material, it has created a new supply chain. One where agriculture, manufacturing, and sustainability work together instead of against each other. Every morning, trucks leave the factory carrying pallets of finished products toward the port of Davao. From there, containers begin a journey across the Pacific. Their destination is not local markets. It is some of the most demanding fashion capitals in the world: Paris, Milan, Berlin, New York, Tokyo. Cities where craftsmanship and premium materials define entire industries. Few customers walking into those luxury boutiques will ever imagine where their new shoes actually began. They will see elegant design, exceptional quality, beautiful craftsmanship. What they will not see is the pineapple field. Some of the very same leaves that farmers once considered worthless now travel thousands of kilometers as luxury products displayed under boutique lighting. Soft, flexible, lightweight, almost impossible to distinguish from premium animal leather. Even experienced leather specialists often struggle to identify the difference by touch alone. That is perhaps the most remarkable achievement of this entire process. The goal was not simply to imitate leather, it was to create something capable of competing with it. And in many categories, it succeeds. Every pair of shoes tells an extraordinary story, a story of engineering, materials science, sustainable innovation, and one simple question. What if the things we throw away are not waste at all? What if they are simply raw materials waiting for someone to discover their value? Factories like this are beginning to answer that question, not with ideas, but with products. Products that people genuinely want to buy without compromising on quality, without compromising on performance, and without relying on animal leather. The next time you see a luxury pair of shoes, take a closer look, because there is a chance they did not begin their journey on a cattle ranch. They may have started life in a pineapple field, waiting for someone to realize their true potential. If you enjoyed discovering how discarded pineapple leaves become premium leather, you are in the right place. Here on Source Code, we take you inside the world's most incredible factories, uncover the hidden engineering behind everyday products, and reveal manufacturing processes that most people never get to see. If you enjoyed this journey, make sure to subscribe, turn on notifications, and join us for the next episode. Thanks for watching, and we will see you in the next episode of Source Code.